All right, hey guys. Um, I'm I'm back. I'm here to talk about something that I kind of been wanting to make a video about for a bit. Um, I think the derivative of the inverse as a topic in calculus is probably one of the hardest topics on the calculus AB exam, and so I'm going to try and tackle it the best I can, um, as well as I can. So the derivative of the inverse is essentially what we're doing is I'm going to talk about it graphically first. So I've made these two graphs here. And so first I think we'll talk about, maybe we have x squared, right? So we have the function goes like that, touches 0. Oh, I missed 0. Oops, my bad. We'll just pretend it touches 0. Okay, so that's our function. We'll call that f of x equals x squared. We have this other function. We'll call this the inverse of f, right? And you could write that like this. The inverse of that equals, whatever you want to say. It's probably plus or minus the square root of x, like that. So those are our two functions. And what I want to talk about is that if I say I want to know the derivative of the inverse at any point along this graph, what I'm really saying is I'm saying, so let's say I want to do it at 1, right? So maybe this is 1, that's 1. Maybe we say kind of there and kind of over there. So at that point there, that's 1 comma 1, right? So I want to know the slope at that point as it relates to its inverse, right? So I want to know kind of at the point 1, 1 on the function. I want to know what that slope is on this function. So here I can say, the derivative of f at x equals 2x, just basic derivative rules. So, the derivative at 1 equals, well, 2. And then I can say the derivative here, we'll deal with that in a second. So this is the slope right there. Okay, and I want to know what that's going to be here. So if we take this function, we know that the derivative is going to be, or sorry, not the derivative, the inverse is going to be over here, because we're taking this graph here and we're kind of tilting it on its side. So this point right there kind of goes over to there. So I'll just erase both of those. And I want to know the slope of this, right? And so sometimes, so x squared is easy because I can take the square root and that's good. But sometimes there are functions that I won't be able to, I won't know, right, or I can't know what this is in terms of x. I'll just know it's the derivative of this. And so the point of finding the inverse, the derivative of the inverse, is to be able to find a way to take the inverse and then take the derivative of a function and know what the derivative of the inverse at that point will be. One kind of graphical thing to keep in mind is, more often than not, I'm not sure if it's always true, but kind of as a general rule, these should be basically perpendicular. Just like as a general rule of thumb, if you take a step back and you're checking, it's by no means a law to say that they have to be perpendicular, but if you're wondering if you're in the ballpark and they're perpendicular, you're probably on the right track. So with that being said, I'm going to jump over here and erase this a little bit, give myself some more room. So what I did here is I took this problem, I went on the College Board, and I went right onto their tests, and they have available for everyone the 2012, the official AP test from 2012, or like the test review packet from 2012. And in section A of the AB exam in 2012, they gave you this question, and I guarantee you, or I almost guarantee you, that it will be on your exam whenever you take your AP test. It's the derivative of the inverse. It's a notorious question. This question was in section A, question number 20 on the 2012 AB AP Calculus test, and it goes as follows. So let f of x equals 2x plus 1 cubed, and g of x equals the inverse of f of x. So they want you to find the derivative of g of x, or the derivative of the inverse, at 1. And so again, this is exactly kind of what we're talking about. You can do it if you have a table, you can do it with a calculator. I'm going to show you how to do it with a table first, then I'm going to show you how to do it kind of algebraically, and I'll show you why it might get a little hairy when sometimes you can't, or you won't be able to find the inverse, be able to work with it numerically. All right, so I'm going to do it, actually I'll do it algebraically first. All right, so if we have f of x, we know f of x is f of x equals 2x plus 1 cubed. Okay, well you find the inverse by switching them. So we can say, okay, well x equals 2 f of x plus 1 cubed. Okay, so the cube root of x, and it's not plus or minus the cube root of x, because the cube root of x, if it's positive, any positive number cubed is going to be positive, and if it's negative, any negative number cubed is going to be negative. If you square it, the negatives and negatives cancel, but if you cube it, they cancel for the first two, and then you multiply by another negative, and it's still negative. So we don't have to worry about that. And so we just have the cube root is 2, oops, I can draw that better, is 2f of x plus 1. Sorry about that background there. So then we have f of x, I'll just skip a couple steps, f of x equals 1/2 the cube root of x minus 1. All right, so we took the negative 1 over there and divided by 2, and so that is the inverse. So I guess this is really the inverse, and that's the inverse, and so is that. All right, so that is g of x as well. So sometimes when we're doing kind of this step in here, you'll run into something and you can't physically get to an answer like this. So there are other ways we'll have to do it, and I'll show you that in other videos. But this is the way I'm going to show you kind of first, because it's algebraic and it's very logical. So this is our function, and we can take the derivative of this function. So the derivative of x, we'll use our nice chain rule here, and then we can remember that we write that as x to the 1/3. Just when we're taking our derivative to make sure we remember to do that. So this is a constant, this 1/2 is a constant out here, so I can just say the constant times the derivative of this piece here, and the derivative of that piece right there is going to be 1/3, so power down, power minus 1, so 1/3 minus 1 is -2/3, and we're going to take the derivative of -1, it's a constant, so it's 0. So we could write plus 0, but we're not going to, and that is the derivative of that. Sweet. So now we can take the derivative of x at 1, when x equals 1, that's 1/2, we're just plugging and chugging here, that's 1/3, and I'm just going to kind of rewrite this like that, because this is actually kind of its own deal there. So x equals 1, 1 to the -2/3, 1 to the anything, really, besides 0 is, including 0, is 1, so that's just 1/6. And that is our final answer. So again, so what we did is we started here with our function, we switched them both, and then we ended up solving down here to get our that answer, or to get the inverse. Then we took the derivative of the inverse here, and then we plugged in the coordinate right there to get our final answer, 1/6.